All right, here's our last video in section 5.4. I want to continue talking about factoring with perfect squares and difference of squares. I know that we've talked about a lot of different factoring techniques, and it's going to get a little bit confusing when they're all jumbled together. So let's practice some more, because the more you practice, the better it's going to be. Let's look at example 4 together. It asks us to factor completely. So we want to factor all the way down as far as possible. Follow your 7 steps. Here we go. For the first one, is it in order? Looks like it. Number 2, is there a GCF? Not on that one. Now let's see how many terms there are. Well, I notice in this one that there are 2 terms, right? And so if there are 2 terms, we're either going to do a difference of squares or cubes. Let's try difference of squares first. Let's see if both of our terms are perfect squares. Can they be broken down equally? Can you take that y to the 4th and break it down? Yeah, it looks like I can take that y to the 4th and break it down into a y squared and a y squared, right? And what's the square root of 16? 4. And as long as there's a subtraction sign in between, this is a difference of squares, and I can factor it into 2 conjugate binomials, y squared plus 4 and y squared minus 4. All right, is that factored completely? Ooh, hopefully you didn't stop there. Hopefully you noticed that one of these is another difference of squares. Not the first one, but this second binomial is also a difference of squares. The y squared can be broken down more, and the 4 can be broken down more. So you should have a y squared plus 4. You can't factor that anymore. But then you should have a y plus 2 and a y minus 2, because we can break down that second binomial even farther. Now it's completely factored. All right, look at B. Is he in order? Yep. Is there a GCF? Oh, it looks like there's a GCF on this one. Please, please, please make sure you take out that GCF. I know that both of those are perfect squares and you could probably factor them right now, but then you'd be missing a GCF in each one. So take out the GCF first, so that way you don't miss it later on. Okay, so take out a 4. When I divide everybody by 4, I have a leftover binomial of an a squared minus 16. Now factor more if you can. It looks like a squared minus 16 is a difference of squares. So I can say a minus 4 and a plus 4, and then don't forget you have a 4 in the front as your GCF. This should be your final answer. If you forgot to take out that 4 and you tried to factor into a difference of squares, it looks close, but now if you notice there's a GCF that you can still take out of each of them, which really means you took out 2 twice or a 4. And so that's the only other way you could have done it correctly. I don't know about you. It's much easier to take out the GCF first so you don't forget. Okay, so be careful with that. All right, look at C. X squared plus 25. It's in order. There's no GCF. There's 2 terms. So let's see if this is a difference of squares or cubes. All right, are they both perfect squares? Okay, well, it looks like I can break up an x squared equally, and it looks like I can break up a 25 equally. So did you say x plus 5, x minus 5? Hopefully not. Hopefully I didn't get you. You notice that there's a plus sign in between? There is no way that you're going to be able to multiply 2 numbers to give you a positive 25, that when you add those 2 numbers you get 0. You get no middle term. This is not a difference of squares. Remember, it has to be a minus sign in between in order for it to be a difference of squares. This problem is actually not factorable. Remember, we call that prime. So be very careful. Make sure you're looking out for that. All right, look at D with me. D, is it in order? Yes. Is there a GCF? Oh, so doesn't it look like I can divide both terms by 2? So let's take out the 2. When I divide each term by 2, I have left over an x squared plus 25. Can we factor more? Remember, it has to be a minus sign in between, so that's not a difference of squares. Now we're not going to say it's prime, because that is factorable. We just factored out a GCF and we were done. So just because we couldn't factor it more doesn't mean that it's prime. So please don't write the word prime. You can still factor that 1. You could just factor a GCF only. Okay? So there's a little bit of a difference between C and D. C you couldn't factor at all. D you could. You just could take out a GCF, and then that was it. Okay? So be careful with that. All right, I'd like you to pause the video. I'd like you to try these 4 try it problems. This will be a good test to see how well you're understanding your perfect squares and difference of squares and making sure that you don't forget anything. So pause the video, try these 4, and then check your answers with mine when you're done. All right, for the first one, it's in order, no GCF. I basic factored it, and it looks like numbers that multiply to 64 that add to 16 are 8 and 8. That looks like it's a perfect square, so you can either write it like that, or you can write it as an x plus 8 squared. All right, number 2, it looks like it's in order. Is there a GCF? Yes, hopefully you took out a 2 and an n. And now my leftover polynomial has 3 terms, no number in front, or really an invisible 1, so we can basic factor it. Numbers that multiply to 100 that add to 20 are positive 10 and positive 10. Those happen to be a perfect square, so you can actually write that as an n plus 10 squared. And don't forget your GCF in the front, the 2n. So this would be your final answer. All right, what did you say for number 3? It's in order. There's no GCF. There's 2 terms. So did you break that down into a difference of squares? Hopefully not, because it's not a difference of squares. There's a plus sign in between. So you cannot factor that one. That one is actually prime. Okay? The only way you could have factored that one is if there was a negative in between, and then you could have said t minus 7 and t plus 7. But because there's a plus sign, that can't be factored, and your answer is prime. It's not factorable. Be careful. All right, what'd you say on 4? It's in order. There's no GCF. There's 2 terms now, so it's not a basic factor. Let's see if this is a difference of squares. Let's try to break 25a to the 4th down and 9 down equally. I did 5a squared minus 3 and 5a squared plus 3. Did you? Perfect. All right, and remember you can also write it with the plus 3 first and the 5a squared minus 3 last. It doesn't matter the order in multiplication as long as you still have those 2 binomials and their conjugates. They're opposites of each other. That one is a difference of squares. All right, make sure that you practice by doing your homework. It's much easier to get a hang of it while you're focused on just one concept, because in a little bit, I'm going to take all of these concepts and jumble them all up, and that's where it's going to get a little bit more challenging, because then you've got to decide what type of factoring is it without just focusing on one type or another. Okay? All right, practice and let me know if you need anything.